intelligence, where where artificial intelligence is very much used. Next one is enhanced communication network. In this enhanced communication network, upgrading the communication networks to ensure reliable, secure data transmission between various data transmission between various components of the smart grid, such as sensors and automated devices and control centers. So next one is cyber security measures. So implementing robust cyber security protocols to protect the smart grid from cyber threats and ensure the integrity of the data and operations. See, here, while using the smart grids, you or IoT devices, you take the data. Okay, so that data, whatever data is there, that should be in a secured way. That should be in a secured manner. Without the security, if there is no security, confidentiality is missing, integrity is missing. Okay, everything is missing. So, due to that, confidentiality, authenticity, integrity, if it is missing, means everything is the data is completely lost. So, these type of measures are to be taken in order to optimize the smart grid. Next one is consumer engagement. So you need to educate the consumers who are using the energy, and you need to explain the benefits of the smart grid technology in order to have the efficient energy usage with the great acceptance, and you need to make them learn new technologies. This is how the consumer engagement need to be done. Next one is decentralized energy management. How you decentralize means you make by using the blockchain technology, you and machine learning and IoT for secure communication, distribute the energy management, decentralize this, and after decentralizing, energy trading among the prosumers are to be taken into consideration. So these are the by adopting these type of strategies, smart grid can become more efficient, more resilient, and capable of meeting the evolving energy demands for the modern society. So again, the same type of thing is explained here. Energy efficiency, reliability, stability, integrity, uh, integration of renewable energy, demand response, cost saving, enhanced security, decentralized energy management, environmental impact, energy, economic growth. Optimizing smart grid is essential in order to for creating a sustainable, efficient, and secure energy system that meets the demand of modern society while minimizing the environmental impact. So, environmental impact means by optimizing the smart grid, we can reduce the greenhouse gases emission and other environmental impact associated with the energy production and consumption. So, this contributes to make the society cleaner, healthier environment, and all these things. And another thing is cost saving. So for both utilities, I mean consumers that means by optimizing the smart grid, which can lead to the significant level of cost saving. Utilities can operate more efficiently, reduce operational cost, and a need for cost, that means upgrading the infrastructure, reducing the electricity. So this will reduce the energy bills, that means electricity bills, like that it can be reduced. So here cost saving is also very much important in optimizing this smart grid. Next one, demand response. Demand response is also is important. Better demand response management, where consumers can incentivize, reduce the energy usage during the peaks. Okay. Next, few economic growth also, it is a reliable and efficient smart grid support economic growth by ensuring that businesses and industries have access to stable power supply. So this can attract the investment, create jobs in energy sector and related to industries. In in this optimized grids, it is very much essential um, uh, very much essential for creating the sustainable, efficient, and secure energy system which meets the demand of modern society while minimizing the environmental impact. So here, this is the difference. Normally, previous distributed electrical grids focuses on decentralizing the production and management of electricity. It involves multiple smaller power generation sources distributed throughout the grid, rather than relying on the few large power plants. Smart grid means it is an upgraded version of traditional electrical grid that uses advanced technology to enhance the efficiency, reliability, sustainability of services. So the main difference means smart grid emphasize technology and communication to improve the existing grid, while distributed grid emphasize decentralized power generation and local management. Next one is scale. That means smart grid often operate on larger, more centralized scale, whereas distributed function on localized scale. Smart grid integrates advanced technologies into traditional grid framework, where distributed grid fundamentally change the structure of how electricity is generated and managed. Now, I told you, no, I have divided this up to here. It is the normal how the smart grid is there, the overview of smart grid and all. Now, I I told you in the starting that I have divided this complete session into three modules. So first one is IoT, machine learning, and blockchain. These are the three different modules, basic things related to smart energy management only. So IoT architecture for smart energy management is given in this particular block diagram. So first, see, if you see, there are different layers. So first layer is a power layer. Second layer is a data acquisition layer. Data acquisition layer is can also be called as a IoT device layer. And next one is communication network layer, network layer, processing layer, or it can be also called as edge or cloud layer. Next one is microgrid control center layer or application layer, or it may also be called as a business layer. So overall, the architectural functionalities, that means architecture will be a flexible, scalable approach to the energy management, integrating various technologies to ensure effective utilization, optimization of energy sources across the domestic, industrial, and remote areas. So now, the first and foremost layer consisting of it is also called as a power layer. So this power layer In this power layer, uh, we are having different types of energy sources and storage systems where we have grid. That means a traditional electrical grid that supplies the power. Next, solar panels. Solar panels, I mean, renewable energy sources harnessing the sun energy. Next one is wind turbines. Turbines capturing the wind energy to generate, that means electricity. Batteries, energy storage system for balancing some electricity on demand. And next one is generator is there. So backup power can be taken, usually powered with some uh, what do you call fossil fuels and alternative energy sources. So overall, the architecture gives you the flexibility and a scalability approach. So if you see this first one, that means you take all the data from battery, uh, from grid, from solar panel, from wind turbines, some batteries, generators. All the data is acquired. That means next one is coming to the data acquisition layer. So that the data, whatever it is taken from the that means physical data, whatever it is taken from the power layer, it may be in the form of a voltage or some sort of uh, data will be taken. That data is acquisited here in this particular layer, from where it is taken IoT devices. That means it is also called as IoT device layer. In this, it is also called as a perceptron layer. It consisting of some sensors, actuators, um, smart devices, which collects the real-time data, interact with all the physical environment from different sources. All the data is accepted. That means some sort of smart meters are taken into consideration, where it measures the energy consumption in the real time. Next one is some energy monitoring sensors are taken. In that energy monitoring systems, some voltages are calculated, are taken. Current is measured, temperature, humidity, and other some sort of parameters, electrical parameters are taken. Some sensors that monitor some environmental conditions also, like some actuators are also used, IoT actuators, IoT devices which control the circuit breakers or smart type of devices, like the thermostats are taken. Thermostats are used. Renewable energy sources are also used, like solar, some panels, turbines, which are associated with some sensors. So all these different devices are considered, and some sensors which measures the weather conditions. So that type of sensors are also considered to predict the energy production from the renewable sources, renewables. So what they do, complete data is taken, real-time data is collected from these energy systems, and wherever some fault is there, though the fault can be detected. That means it detects the anomalies, like anomalies in the sense some voltage spikes may occur, some power outages may be there. All these different types of anomalies are taken into consideration, and it enables remote control appliances and energy sources. All these things are taken into consideration. Next layer is communication network layer. So in this communication network layer, we use different types of that means it is also called as a cloud or edge layer. So in this we use some protocols. So we generally use the protocols like some we may use them LoRa. We use some uh, uh, we generally use Wi-Fi. In that Wi-Fi also you use Zigbee, LoRa. LoRa means it is a low power wide area network. So that type of technology is which is very much suitable for IoT applications, and narrowband Internet of Things is which is designed for improved indoor coverage and low power consumption. So this is also used. Next, Wi-Fi and Bluetooth are used. Now, generally, wireless communication technologies for local communications, and wired Ethernet cables can also be used for some power line communications can also be used. And in order to, that means some sort of gateways where there may be a intermediary between IoT devices and cloud systems, which translate various protocols to ensure seamless communication. All these things are used as a gateways, and some edge devices means edge routers, mini servers. That means edge devices means local data is there. That means like from CC cameras, like that, local devices process local data locally to reduce the latency. All these things are used in this particular component. That means the protocols are used in this particular layer. So it ensures the secure and efficient data transmission is used. But few type of that means algorithms are incorporated in order to use this security in this particular protocol. It enables the real-time communication between device and some sort of communication. So here it manages the data aggregation and multiple from the multiple different sources. So here these are the different things which are used, and edge computing and cloud computing are also different components which are used for large amount of data. If you see, if you want to collect large volume of data by the IoT devices, for example, if you see traffic signals, CC footages are there. Large amount of data. It is completely very large amount of data. That type of thing, analytics is very much important. Analytics while you do, then these type of cloud type of massive data, historical data, huge data like weather data, everything is very much huge. So then such type of uh, computing is done. So generally in edge computing, real-time analytics, very much close sources in order to reduce the latency, it is used, and it is very much suitable for that means it is time sensitive. Time sensitive. That means uh, false detection can be done. That means demand response, depending upon the demand, the response is very much fast. Like this, in that cases, edge computing is used. Cloud computing is, I told you now, very much. That means huge data if it is taken, real-time data if it is taken, then such type of cloud related things are. Now, in this, we use artificial intelligence and machine learning models for predictive analytics and optimization. So, in order to have some security, we use some cryptographic algorithms. So these cryptographic algorithms, the high-end version is some sort of, that means blockchain, blockchain is also used in order to improve the security. So it provides secure and decentralized data storage for energy transactions and device authentication. So these type of things are the functionalities and are used for this. So here in this data is filtered, pre-processed, data is completely run. Some ML models are taken for demand, that means for forecasting some any faults. That means anomaly detection, energy optimization is also done. So such type of things are used for as a functionalities. Now coming to the application layer. Application layer means here we use this application. That means whatever applications we generally use means in business oriented utilities, end user. Application means end user. It interfaces with the end user, utilities, and other stakeholders by providing some actionable some sort of insights and control mechanisms. In this, some components are there. The components are energy management platform is one component, mobile and smartphone application is one component. Grid management is another component, and the smart contracts means is completely related to blockchain. It is not related to any sort of thing. Data is taken. Here data is to be transferred from one peer to another peer. That means peer to peer energy trading, automate the energy transaction. So such type of things is smart contracts is used. Now energy management platform is used in this general dashboards for monitoring the energy usage, how much energy it is used, in what way it is used, what is the cost, all the things energy management platform in this layer you can see. Next, some sort of alerts and recommendations for optimizing the consumption. All these things we will check in this energy management. Next one is a mobile or smart app. Enable remote control, IoT enable applications, provide energy usage, reports and demand response notification. All these things are used. Next one is that means some policies are also incorporated here in the application layer, which is related to business. That means they set some rules. Policies means some set rules for energy trading, demand response, and renewable integration, or building the tariffs, market integration, dynamic pricing based on the energy demand, interact wholesale energy market by buying and selling the power. So all these things are used in the business layer or application layer. So it defines the policies, strategies, services. All these things are used in this business. It establishes, it gives the operational protocol for the IoT enabled smart grid. Okay. So it generates insights for decision making to improve the energy policies. It supports the business model like peer-to-peer trading, renewable energy incentives. So this is the structure. This is the four-layer architecture of IoT where we generally use for the smart energy management. Now, in this smart energy management, we generally use different types of devices and different types of components, like smart meters we use. These devices measure, that means measure and record energy source, smart meters, insights the consumption patterns, and these devices measure and record energy usage, provide detailed insights in the consumption pattern, devices installed at consumer sites that measure the energy usage and can control various applications, and uh, data data at the remote place or automated control devices are taken into consideration. These energy consumption and these energy production are all the data is taken, and smart energy is controlled here. And this is one type of energy. And another energy source is solar, wind, and grid. These are original points of energy generation, renewable energy sources with some traditional grid. It gives diverse energy inputs. In this smart grid, um, advanced electrical grid, which uses the digital communication technology to detect and react to the local changes, which is used efficiently, distribute the electricity from source to the consumer with minimum loss. So these are the things which we are using here. And the total energy source, that means end user means homes, industries who utilize the energy ranging from starting, that means minimum homes to the larger industries consume energy based on the demand, which can optimize through the IoT. Okay, so all these things are utilized. Here, edge computing is used. Local process units, that means handle the data communication close to the source, reducing in order to reduce the latency, perform real-time analytics, taking the decisions aptly without relying on others. That means solely on the relying on cloud infrastructure. At a stretch, you can get the predicted answer. Next, some sort of sensors are used. Sensors and actuators are used, which collect the data on energy consumption and environmental conditions and other parameters. This real-time data uh, is collected, and this in this data, temperature may be one type of thing, environmental conditions, time data, energy consumption, all these are different types of things. And actuators can also be are also used to perform some actions like adjustment, light turn off, line controlling. All these things are used. Next, communication networks. Already we have discussed about some edge computing and fog computing, where some protocols are used. In generally in a large area means it is some protocols like MQTT and HTTP type of things are used. Hypertext transfer protocol and message queuing telemetry protocol is used. In edge means local area network like Zigbee, ad hoc type of protocols are used. And all these are different types of protocols which are used in this communication network. Next, coming to the data analytics. In this data analytics, the components process and analyzed and collected the data to identify the trends, uh, which are which gives the opportunities for saving the energy. Here you can utilize the cloud computing to store vast energy, vast amount of data, a vast amount of that means apply machine learning algorithms in order to get the predictive analytics. So here, if you use cloud means the you can use a weather type of report. All these things you can use and optimize the energy distribution on larger scale when you use when you use the cloud. Next one is control system. These systems are used to analyze the data and automate optimize the energy usage by setting some sort of lights, turning off lights and all these things you can controlling. Okay. Next one is user interface, like applications and dashboards. This interface allows user to monitor and control their energy consumption, providing insights and recommendations for further optimal optimization. Access the platform by for the user to monitor their energy consumption, receive notification, and control the device. So this is one of the architecture where we can also here. If you use the cloud, you can use the some sort of big data system is also used. Okay. Next, what are the how the data flow in the architecture is done? In what way the what are the benefits of this IoT architecture for a smart energy system and the key technologies which are used? So you take the everything what where in all the three modules, data collection, transmission, processing, and get the feedback. This is what the thing is. So in IoT system, Internet of Things system, you collect the data. That means Internet of Things means it is a sensor based. Here, sensor based means you gather the data. That is called as data collection. Transmit the data. That means some gateways may be there. It may be edge computing platform or cloud computing platform using some secured protocols. Some secured protocols means you are using some cryptographic algorithms there, and using those cryptographic algorithms, protocols, and different gateways, you transmit the data in order to send securely. Data is processed, real-time analytics is done, and optimize the energy. That means reduce the peak loads. How you reduce the peak load means you implement machine learning models, and predict the energy trends. Okay, so these are the things we generally use here. Next, depending upon that prediction, control commands are sent back to the device. That means if there is any failure, you need to do the rescue. You need to change the change the device. That's that type of things. That means feedback. Okay, so alert are sent to the user via application, some sort of things. That means feedback is done. Now, what are the benefits of IoT architecture for this smart energy management? There are several energy, that means energy efficiency, it reduces the energy wastage by optimizing the consumption. Cost saving, dynamic pricing and demand uh, response lowers the cost, energy cost. Reliability, real-time fault detection improves the grid resilience. Sustainability facilitate the integration of renewable energy sources. Consumer empowerment provides transparency and control over energy. These are different things. Key technology in architecture, IoT architecture. These are machine learning, blockchain, 5G connectivity, edge computing. Machine learning is used for predictive analysis and optimization. Blockchain is used to secure the data and enable the decentralized energy trading. And 5G connectivity is used for ultra low latency in the data transmission. Edge computing is used to process the time sensitive data locally. All these are taken into consideration. What are the benefits means you are having energy efficiency, cost saving, reliability, sustainability, and consumer empowerment. All these things are taken into consideration. Now, what are the applications? Applications means in this we are having an IoT application for smart grid. The smart grid it increases the efficiency, reliability, sustainability. Some applications for this smart grid are grid monitoring management. Grid monitoring and management. It takes the sensors, deploy across the substations and transmission lines, capture the real-time data. Real-time data means on voltages, current, and other different parameters. This data helps utilities monitor grid health, detect the abnormality, and proactive the address where the potential issues are there. This is called as grid monitoring and management. Demand response optimization. So this is one of the application. So it enables smart grid, allows the utility implement the demand response program efficiently by integrating smart meters and IoT devices in homes and business utilities. You can remotely manage, optimize the energy uh, during the ups and downs. That means peak hours, or we can call it as peak hours. Distributed energy resources integration. So in this distributed energy resources, so smart grid leverage the IoT to integrate renewable energy sources and energy storage system and electrical vehicles. This integration allows the efficient management of distributed energy sources, which optimize their contribution to the grid. Okay, this is next one is predictive maintenance. So IoT sensors plays a very important role, very crucial role in predictive maintenance by giving the real time insights to the condition of grid components. By continuously monitoring the equipment health, utilities, and identify the potential failures before they fail. Okay, the energy supply management, in this energy supply management, uh, IoT applications enable smart management of energy supply, including some managing the electrical vehicles, charging stations, and optimizing the battery, everything. So this is about the IoT, where the smart grid is implemented. This is one of the module which we see, and I have a small video where the IoT application for smart grid is So this is a simple snippet of a video which I created in our artificial intelligence. So coming to the next module is machine learning application for smart grid. So, machine learning is one of the major major concept where in any sort of that means subject you go, either it may be any subject you go. That means either it may be a automobile, either it may be mechanical engineering, electrical engineering, electronics, even if it is physics, mathematics, any sort of things, wherever you go in medical field, in design field, wherever you go, machine learning is there, artificial intelligence is there. So in machine learning, there are different types of machine learning. Uh, See, machine learning has a wide, till now we have seen the IoT. Now coming to the machine learning. In this machine learning, it has wide range of applications for the smart grid, which is related to smart grid, if you see, which are advanced electrical system designed to effectively manage the generation, distribution, and consumption of electricity. Now, in this, we are having some key applications are load forecasting, fault detection, and diagnosis, some energy management, demand response, anomaly detection, and grid optimization. So all these are different applications which are used, which are there in the machine learning for machine learning applications for smart grid. Now, before going to the applications for smart grid, we need to know what is the main thing. That means what is machine learning, in what way the machine learning is used in the smart grid. So, machine learning it makes the computer learn, may make the machine learn. So here we are having four different types of machine learning models. So first is supervised learning. Uh, Second one is unsupervised learning, semi-supervised learning, reinforced learning. So the first one is supervised learning. Here in this supervised learning, we take the training data which is labeled. The data which is taken, it is trained and it is labeled. So after the data is labeled, uh, it finds that means some sort of mapping is done. So after mapping is done, you get the prediction. So it may be used in many areas. In many areas, this type of supervised learning is incorporated. Now, number of algorithms are there for supervised learning, like K nearest neighbor algorithm, decision tree algorithm, neural network. I think many of you know about this neural networks, support vector machine, logistic regression, and linear regression. These are the things which are used in this. That means these algorithms are incorporated in this supervised learning. Some examples related to this supervised learning are some house price prediction, medical imaging, intrusion detection. That means prediction for intrusion detection. You take the labeled data and train it and give the test data. Automatically you get the prediction of whether it is whether the output is reliable or not. You get the prediction value. This is supervised. Unsupervised means the training data is completely not labeled in the sense it is not given any name extra. That means it extracts the general structures. In this, we generally use the what do you call some algorithms like k-means clustering, self optimizing maps, principal component analysis, PCA, like this, different types of algorithms are used. K means clustering means some clustering algorithms are used where all the similar kind of labels are kept in one particular cluster, even though if it is not labeled, the trained data completely one particular area, it is called as a cluster. So in that cluster, it is kept, it is segregated, that means separated. Like, for example, some traffic clustering is one of the examples here. Customer segmentation is another example, and when you go to a market, keep a basket, you go with market basket analysis. This is one of the example. Next, next one is semi-supervised learning. In this semi-supervised learning, semi-supervised learning, the training data is mix. Mix means there may be some labeled data, there may be unlabeled data. Here we use, this is used for some resource management, text classification, and GPS data is also taken into consideration. This is one type of data which is used. So here some algorithms, generative model algorithms are used, maximum likelihood learning model is used. Next one is reinforced learning. Learn from the experience. See, one learn from the experience based on the reward feedback. That means whatever feedback you get, depending upon that you go. So like that, it is there. In this, Marco decision process is one algorithm, and some algorithms are there. Driverless car is one example, and decision making is another example, and computer games, that means chess games, is another example. In this, so generally, all these four models, if you take a live example, so supervised learning means go to a teacher, learn something, whatever teacher says, that is the from there you learn and get you implement something. That is supervised learning. Unsupervised learning means um, uh, you you uh, you will not be taught, you don't go to a teacher, you learn by yourself. Okay, so that is unsupervised learning. Semi-supervised learning means some concepts you learn, some concepts you don't learn. For some concepts teacher will be there, some concept teacher will not be there. That is semi-supervised learning. Reinforced learning means, see, from the childhood you go to a cycle, ride a cycle without any teacher or anyone. You try to learn. You fell down. Again you go. Again you learn by experience. You can understand that you should not do such type of things. You can do such type of thing. This is called as reinforced learning. That is, by experience you get all the things. So depending upon the previous experiences, that if you fail, you get some other inputs. If you don't do such type of things, you get you may get the ideas, and you can do another type of thing. That means by experience, by getting some feedback, reinforced learning is used. Now, I told you that you are having some applications, machine learning applications for related to smart grid. In this smart grid, ML model, ML applications for smart grid, machine learning has a wide range of applications in the smart grid. which are advanced electrical systems designed to efficiently manage the generation, distribution, and consumption of electricity. Some examples, some applications are load forecasting, fault detection and diagnosis, energy management, uh, demand response, anomaly detection, and grid optimization. These are the things. So, ML algorithms can predict the electricity demand based on the historical data uh, or weather conditions and other factors, which help optimizing the generation and distribution of the power. Fault detection. It identifies, diagnoses the fault in the grid in real time, reducing the time and cost maintenance. Energy management helps in optimizing the use of renewable energy, uh, such as like solar and wind, predict the output, integrating it. Okay. Next one is demand response. It analyzes the consumer user pattern, adjust adjust the supply of electricity accordingly. That means accordingly to the balance of supply and demand. Okay. Next one is anomaly detection. Anomaly detection means some sort of faults, unusual patterns may be there in the grid. Such type of unusual patterns, some cyber attacks may be there, electricity theft may be there. So these are some sort of anomaly theft that can be found out in this. That those are the applications. That means you can get. Machine learning techniques can optimize the operation of the grid by finding most effective, most efficient way to distribute electricity, reduce losses, and improve overall performance. So these are the things which we generally use. Next, coming to the architecture. So this is the architecture of a, smart grid with machine learning and deep learning integration. So in this machine learning and deep learning um, deep learning integration, smart grid architecture is shown, and how the data flow in the machine learning or deep learning, how it is represented, how the models are used. Here, the internal data or data is taken, or external data from the cloud it is taken. All the data is given to the machine learning model, and data is data completely it is acquisited. That means collected. It is pre-processed, and all the pre-processed data consisting of some features, and these features, the data features, are given are stored, and some sort of explanation is given by the that means given by the ML models, and due to that explanation of the ML model, training is done, and after that means the data which is taken is completely optimized, decision is taken, and the data is it may be a voltage, temperature, humidity. Different types of data can be taken from either from IoT data or weather data or whatever data, electrical grid data, or some data is taken. It is uh, taken and trained and given to the model. Real time data analytics is done, optimized, integrated, validated, tested, trained, and output is visualized in the form of a report. In the form of graphical representation, you get the output. This is how the data flow and the machine learning based smart grid application is done. So this is the model which we are presently doing, trying to implement this. A review is going on in this model. Machine learning algorithms can optimize, integrate, and manage the renewable energy sources into the grid. These models can forecast the renewable energy generation, optimize utilization, and facilitate effective grid balancing and energy storage strategies. By by leveraging these learning techniques, a smart grid can that means it can reduce the challenges, improve the operational efficiency, enhance the grid reliability, security, optimize the energy utilization, and engage some consumers in the sustained energy practice. So next, coming to the load forecasting. This forecasting, again, we are using it is also a flow chart where workflow is there. The load forecasting using the machine learning, deep learning models. And in this, data is collected, data is processed. Data means either it may be a historical data, that means historical load data, previous load data, weather data, either it may be a temperature data or humidity, time of day, day of the week, and other relevant factors is considered in by taking this collecting the data. Data is typically obtained from where you collect the data. That means you can collect from IoT, you can collect from smart meters, you can collect from the grid sensors, you can collect from some weather warning stations, you can collect from historical data. All these different areas you can collect the data, and it is pre-processed. Okay, what is pre-processed means some sort of noise may be eliminated, data is cleaned, uh, data quality is taken into consideration. It is to be compatible in order to have the output without missing the original data, cleaning the unwanted data, and we generally normalize the data for further analysis or future analysis. Further analysis or future analysis means you are doing the feature extraction. So here features are relevant features are extracted from the collected data that can capture either it may be in ones and zeros. That means weather related data also you can convert it into binary data or some other data you can collect, you can convert. Historical data patterns you can check. Like that, different types of features you can take into consideration. Next one is model selection. See, after getting the after having the feature extraction, you can see the model selection. What type of model you need. That means which machine learning model you want to implement, like artificial neural network, recurrent neural network, or long short-term memory LSTM network, or support vector regression, or random forest regression. Like this, different types of models are there. Which type of models, depending upon which data, depending upon the data you are having, these type of algorithms or these type of models are taken into consideration. Okay, so after that, training is done, training the model. So the selected model uses the historical load data and corresponding features. The model learns by putting the patterns and relationship between the input features and output features, input features and target load values. Training, which involves the optimization techniques, are also incorporated by using some back propagation gradient descent algorithms, and other learning algorithms are also implemented for this training and development of model. Now, next one is validation is done. How the validation is done means by validating you using a separate set of validated data to assess the performance of this uh, this data. The evaluation metrics can be done by mean absolute error, mean square error, or root mean square error, or and are used to quantify the accuracy of the model's load forecast. All these things are considered in this model. Next, again, the benefits of this uh, doing the load forecast is by having, that means efficient generation distribution is one of the benefit. That means accurate demand forecast, which allow the power plant to or plants to adjust the output, reduce the waste, and ensure the stable supply of electricity. Cost saving is also considered. Utilities can reduce operational cost by resources, optimizing resource allocation and minimizing the needs for uh, expensive type of, that means uh, peaking the power plants. Okay. Next one is enhanced grid stability is one of the, by anticipating demand fluctuation, grid operations can prevent, take the preventive measures to avoid, that means breakdowns, okay, or blackouts or some sort of things, right? And next one is integration of renewable energy. Better load forecasting help integrating the renewable energy by predicting their contribution and balancing it with some sort of normal traditional power generation. Overall, the load forecasting using this machine learning lead to more resilient, cost effective, environmental, and um, uh, all these things are environmental friendly power grid. All these things are okay. So next one is this one, fault detection and uh, fault detection and diagnosis. So here also the flow is done like this: data acquisition, pre-processing, feature extraction, machine learning model, training model, fault detection, alarm generation, up to this part. That means fault detection up to training part. It is common, same. That means depending upon the that means model, you will be having the, that means fault detection. You it is a process in which a smart grid uses typical uh, smart grid steps, and it involves a systematic process to identify the faults or abnormalities. Okay, so in this fault detection, one model, once the model is trained, they are deployed to analyze real-time data from the smart grid. The model continuously monitor the incoming data and compare it with the learned patterns. Okay, it deviates if any sort of deviation is seen, or any sort of anomaly is seen uh, beyond a particular threshold value, it indicates the presence of a fault, or fault is then the alarm is generated. Okay, so when the fault is detected, alarm is activated. Okay, notified the grid which operates the maintenance, and that means maintenance person will go and go to that particular location. Okay, so machine learning model can assist in correlating fault patterns with a specific sort of grid elements, like either it may be a transformer, circuit breaker, or any sort of thing. Okay. Next one, response and mitigation. So wherever the fault is identified in a local area, it appropriately mitigates the fault, go there and try to restore it. This that means or isolate it. That means or remove it from that particular location. So this is done in this. So here, what are the benefits? Early detection, cost saving, improved reliability, automated diagnosis, predictive maintenance are done. Next, energy management using machine learning. Everything is the same. Again, everything is on data collection, data pre-processing, model training. From here, it is changed. Data optimization, decision making control, continuous learning adaptation, and performance evaluation, integration with smart grid infrastructure. So all these things are separate. So here, after training, deployment is uh, deploying the training and evaluated models into the energy management system. Now it is optimized. Once the model are trained, they are deployed to optimize the energy management process, which involves various aspects such as demand response, load scheduling, and energy storage management, renewable energy integration, grid operations optimization, model analysis, real-time data analysis, prediction, generation, optimization, strategies different strategies to um, uh, achieve the goal, desired objective. Next one is decision making and control. So optimization strategies which provided by the machine learning model are integrated into control system and the decision making process. These strategies guide real-time energy consumption, distribution, and all continuous learning and adaptation. Energy management optimizes system using machine learning algorithm, operates continuous learning. If continuously new data is obtained, newly it updates the model and adapts the changing depending upon the conditions, patterns to ensure to get the optimized result and improve the performance. So in performance evaluation, performance of energy management optimization system is regularly evaluated to assess the effectiveness. So this is about performance. Now integration with the smart grid infrastructure. Optimized energy management strategies generated by the machine learning algorithms are integrated into the smart grid infrastructure. The integration enables coordinate between various grids, um, energy generations sources, energy sources. All these are integrated. The communication is done, and this energy management optimization utilizes energy consumers and achieves significant benefits like again cost saving, improved energy efficiency, all these things, increased renewable utilization, uh, and better grid stability. All these things are done. Next one is benefits. So what are the benefits which we are having means it is predictive analysis, demand response, optimization algorithm, energy storage, and this one, consumer behavior analysis are the energy management. Next one is demand response. Demand response refers to the system where electricity demands is managed dynamically to align with the supply. Supply ensuring grid stability and efficiency. Machine learning is highlighted as a tool implementing demand response, analyze consumer user pattern, adjust the supply of electricity accordingly. The goal is to achieve equilibrium in the energy system. It correctly identifies the role of the machine learning in demand response. Okay, so all these are depending upon the demand response. This doesn't have any. Next one is anomaly detection. Anomaly detection means it identifies unexpected behavior in the system. Machine learning is capable of performing the anomaly detection. Cyber attacks are targeted with the grid security, unauthorized consumption, manipulation of electricity, ensuring the security and reliability of the system. Ultimate goal is to maintain the grid stable and secure. Okay, so it illustrates the practical applications of anomaly detection. Secure and reliability is taken. How machine learning detects the anomalies, such as by using some sort of classification models and or unsupervised learning models. So using this um, machine learning can detect unusual patterns in the grid, such as cyber attacks, electrical theft. You can reduce you can increase the security, reliability, efficiency, and energy. Next one is grid optimization. In this optimization, again, all the things are same. Decision making, real time monitoring, grid resilience and fault management, performance evaluation are are the things which are extra. Here also potential improvement is taken into consideration. It mentions specific optimization scenarios such as managing peak loads, integrating renewable energy sources, reduce the carbon emissions. Machine learning achieves optimization such as through predictive analysis, real-time monitoring, and reinforcement learning. Okay, so these highlight other advantages such as cost reduction, enhances sustainability, and fast response and disruptions. Machine learning technique can enhance grid operations by identifying the most effective ways to distribute electricity, managing peak loads, integrating renewable energy sources. Okay, this is about grid optimization. Now, related to machine learning applications for smart grid. So we have completed the machine learning concept. Now coming to the blockchain technology applications for smart grid. Okay. So now in this smart grid uh, application, that means blockchain technology applications for smart grid. Here, if you see the user is there, smart contracts is there, and user is there. Here, transactions is there. Transactions is there. That means transaction in the sense I am transaction. That means I am giving some money to the other part, and he is taking the money from the from some other service. That means payments are done peer-to-peer. Payments are done in peer-to-peer transaction. That means trading is done. For example, trading means either it may be power transfer is also one type of trading, where smart contracts is one sort of a code which is a self-executing piece of code which is stored on the blockchain that automatically enforces some rules and regulations in terms between the parties without any intermediary. Okay, so it will be converted in the form of blocks. Each and every block will be having some sort of security. So it is very much difficult to break the block. And if at all, if any sort of hacker is there in order to break the wall, so it is heavily very much difficult to him to get the complete data. Okay, so here smart contracts are utilized so to check the nodes, verify the blockchain. It is given to the data to the blockchain. Every data is kept in the block. So this type of transactions is done from user to user. In between user to user transactions, some smart contracts are there. Okay, so it clearly defines what the smart contracts will do. It trades, manages, automate the payments, identify the required inputs, outputs, and conditions. Okay, Here, some sort of platforms are there. The platforms you for the blockchain are Ethereum. Ethereum is one platform, and this with a programming concept called as solidarity. Solana is another type of platform which high performance blockchain supporting smart contracts. So this is one type. Next one is these are different types of contracts which are used. For local type of transactions, Ganachi is one type of platform, and it is used for simulate different types of scenarios for testing. And for compiling the smart contracts, we generally use Sol. That means Sol means it is a Solidity compiler. It converts the code into machine readable format. It takes the byte code. The code runs on the blockchain. Deployment is also done, which connected to the blockchain. Now, a smart contract which adds the blockchain to get the records, address, and the state of the transaction. That means you will be having
ఆగండ్రా ఏంది
you will
అయిపోయిందా
you you will be having you
ఆగండి
will be
నాన్న
having some blocks. In this blocks, you may be having Genesis block 0, block 1, block 2, like that, block n. N number of blocks will be there. You will be having a code, that means hash code, nonce, timestamp, Merkle root, and a number of transactions. So these are different types of blocks which is connected. One block is connected to the another block. So block identification will be done by using a node. That means it is a block. A block in the blockchain is similar to the link of a chain in the field of a normal cryptocurrency. Block like records store the transaction like a record book, and it is encrypted. So it is completely a type of thing where you will be having an identification. That means it is called as header, and the header will be having some address, and that address is called as a block address. That address is also called as hash of block 0. Initially, Genesis is a block 0. That means total one is block 0. For that, you will be having a block 0 is the initial one, and nonce means it is one type of number used only one particular number, central part of proof of work. Okay, so there are different types of algorithms where we use some sort of consensus algorithms are used in this transaction. So here consensus algorithm are used in between this transaction. There are n number of transactions here. For every block, one block is connected to another block, one block is connected to another block. Like this, it is connected. It is peer-to-peer energy trading. Secure energy transactions is done. Enhancing data integrity is done. And cyber security is taken into consideration. That means in order to reduce the cyber security, this data storage management is considered. Here, consensus algorithms are of different types. So one type of consensus algorithm is a proof of work, proof of stake, delegated proof of stake, uh, practical Byzantine fault tolerance. All these are different types of consensus algorithm which are incorporated uh, in the blockchain. Okay, these are different algorithms, means these are different types of protocols, different types of protocols which use for security, scalability, decentralization, energy consumption, and false fault tolerance. So, how the proof of work, how the stake works. So, the security is high, secure scalability is low, decentralization is high, energy consumption is very high, fault tolerance is very high in this proof of work. Like that, every work is considered in this consensus algorithm. So here, there are some sort of network will be there, which is called as blockchain fork. This is called as a blockchain fork. So in this blockchain fork, it occurs when blockchain network diverges into two separate paths, changes its protocol, differences in data interpretation, software updates are there. Then folks are the becoming the fundamental aspects for the blockchain system, and either it leads to temporary network split, or permanent changes in the blockchain. This is the world one. Here you see the split. This is one's old one. This is the new one. So this is the genesis of the block, and this takes the diversity here. This will become the new one, and this is the old one. Here there are different types of blockchain forks are there. The first one is soft fork, and second one is hard fork. The soft fork is a backward compatibility upgrade where only previously valid blocks become invalid. Okay, so a reduction in block size limited where blocks exceeding the limited are no longer accepted. So these are the soft fork. And hard fork, non-backward compatible changes to the blockchain protocol where all the nodes must be upgraded is the new to the new software. This is about hard fork. Okay, so these are as the time is uh, very, that means it is speeding up. I am fastly moving to the next slide. Okay, so here we are having two types of valid stake block and orphan block are there. Orphan block have no parent, and so they can't be validated. And this stale block is a valid block that was mined but not added to the longest chain because another block was mined and accepted by the majority of the network first. So this here a block type structure is will be there where complete data is completely secured. This is about the blockchain. Okay, so blockchain enabled future smart grid will be represented like that. Information flow will be there, energy flow, energy trading. Blockchain is taken, a meter, smart meters are incorporated, and every data is given to the control center. Okay, so now blockchain enabled future smart grid will be like this. Secure energy transactions will be done in this decentralized digital ledger technology will be considered. Guaranteed. It ensures guarantee, provide assurance, protects against unauthorized access, and makes the transaction process clear, visible, all authorized participants, and tamper proof prevents alterations on manipulation of transaction records. So by reducing the risk of risk of fraud and unauthorized access, minimizing likelihood, dishonest illegal activities aimed at deceiving others, that means unauthorized access, gaining access to the system or data without proper permission. Okay, so this is about blockchain enabled future smart grid. So in this, it focus blockchain to enhance functionality, efficiency, smart grid, peer-to-peer energy trading, with which improves efficiency, transparency, and security. And it is through a decentralized ledger only smart contracts is used. Okay. So this is another video where blockchain technology is next. We will go integrating the integration of optimization, data collection and communication, IoT and blockchain. Continuously, IoT device collect real-time data, energy generation, and consumption and grid status. Blockchain ensures secure and transparent communication between IoT devices, preventing tampering and cyber attacks. Data pre-processing and decision making with IoT and machine learning. ML models process IoT generated data to optimize load distribution, predict maintenance, needs and forecast demand. This result in improved efficiency, reduced downtime, and lower operational costs. Energy transactions between blockchain and IoT. Blockchain facilitate decentralized energy trading, while IoT meters provide accurate real-time data for transaction, which empowers consumers and prosumers. Okay, in the decentralized energy market. Autonomous optimization, machine learning, and blockchain. Machine learning model identifies inefficiencies, anomalies, like then automate grid adjustment via smart contract on blockchain. This enables self-healing grids that automatically reroute the power during outstages or adjust to the fluctuations in the demand. So general practical uses. So our demand size management is one of the practical use. Decentralized energy market is another practical use. And grid resilience is and fraud detection. Integration of renewable energy is another practical use case. These are the things. So now this is the last slide where integrating machine learning, blockchain, and IoT. This is the last one.
పిల్లల కోసం వాళ్ళని పిలవలేదు. ఫస్ట్ వాళ్ళ దగ్గర ఇట్లాంటి ఉన్న నాలెడ్జ్ ఉన్న వాళ్ళ దగ్గర నుంచి ఒక FTPలో లేకపోతే
కృష్ణయ్య తలారి ప్లీజ్. కృష్ణయ్య తలారి, ఓకే.
ఈ నాలెడ్జ్ ఏదైతే పైథాన్ ఎక్స్పర్ట్స్ ఉన్నారు,
కృష్ణయ్య తలారి ప్లీజ్ మ్యూట్ యువర్ మైక్రోఫోన్ ప్లీజ్.
వీళ్ళు ఇప్పుడు పక్కన ఇంతమంది ప్రజెంట్ చేసేవారు సందీప్.
ఓకే.
So thank you, sir.
Thank you very much, sir. So great applications of AI, blockchain, and IoT, sir. Really, we could see the not only listening to the theory, you also shown us the practical implications of the
yes, sir.
their technologies, how the technology have evolved and grown, sir. Really great, sir. So, dear participants, faculty friends, if you have any query, you can ask, sir. You're most welcome. This is a session for 1 or 2 questions, please. Anyone, please? Any participant would like to, because this is an advanced AI, blockchain, and artificial intelligence are, sir, it is a really advanced topic, sir, for us. If there is no questions from participants, with which we would like to thank our dear professor, Sivarao sir, for delivering such a nice lecture in this FDP. Thank you, sir. Thank you very much.
Thank you, sir.
Thanks. So please continue for our valediction for a few minutes, sir. We're going to start. Now, I would like to hand over the session to the chairman or president of the FDP, Dr. D. Lingaraj Garu, head of the Mechanical Engineering Department. Sir, are you there, sir? Dr. Lingaraj Garu?
Lingaraj Garu? Yeah, he's there.
Yes, sir. Yes, sir. So now I'm handing over this session to President of the Valedictory session, Dr. Lingaraj Garu, Head of the Mechanical Engineering Department. So participants, we would be continuing our FDP with the validation for valedictory first, and then we'll proceed with our test.
జాయిన్ అవ్వలేదు మీరు
Lingaraj garu.
అసలు మాకు వినిపించట్లేదు. వీఆర్ అనేబుల్ టు హియర్ యూ.
Yeah.
And you switch on the audio also, video.
Hello.
Lingaraj, sir.
Sir, am I audible?
Yes, sir, you are audible, sir. Please,
Sorry, my speakers maybe
turn on your video also if possible.
Yes, problem maybe with my hand phone.
Okay, sir.
I thank Dr. Dilip Kumar for giving this expertise and inviting me for this session. On behalf of the Department of Mechanical Engineering, I congratulate the senior professor V.V. Subbarao Garu and Dr. Dilip for your valuable efforts towards achieving this Atal program from ASTE. And I thank ASTE for sponsoring, as well as I thank our college administration and university administration for providing all the facilities to organize this event. And especially I thank all the speakers as well as the participants, because this is the program which is run in the odd session from 6 to 9 p.m. almost. Every day I'm also there throughout the presentation, more than 100 participation for every session. So I thank your wholehearted contribution, sparing your valuable time for each and every participant, as well as the speakers. Even two foreign speakers, in their odd time, they spend a lot of time. I thank both the speakers as well as the participants from the department. And now I request our Vice Principal Administration, Swaruparani Garu, to address the gathering.
లింగరాజ్ గారు. ఎస్, లింగరాజ్ గారు.
Sir.
First coordinator.
I request Professor V.V. Subbarao Garu, coordinator for this program, to address the brief remarks about the program.
Yeah, thank you, Lingaraj Garu. Yeah, a big thanks to the participants for their active participation during this 6 days. Really, it is a Hercules task attending online every day 3 to 4 hours. 3 hours means it is a big task. But you have made it the program successful. I thank all the participants and welcome and to this evening function, valedictory function. Yes, thank you all. And the president of the today's evening function, head of the department, Dr. D. Lingaraj Garu, and guests of honors of this evening function, Mr. Professor M. Swaruparani Garu, Vice Principal, and Professor G.V.R. Dikshitra Garu, Vice Principal, Academics, and Swaruparani Garu look after the administration of the college, and the chief guest of the our evening function, Professor N. Mohan Rao Garu, and participants of the program. Very good evening to one and all. Yes, this FDP, emerging technologies in optimizing renewable energy systems with smart materials and storage solutions, organized from 20th January to 25th January, with the support of all of you know that it is AICT sponsored program, Atal. Yes, hope the participants have enjoyed a lot during these 6 days. But here the speakers are drawn from premier institutes and as well as from the industry also we have drawn. But here participants, it is difficult for any speaker giving a comprehensive understanding to the participants means it's not an easy task. Here, the experts are delivered their lectures on the recent technologies. So recent technologies means which are not available in the textbooks or but they are research topics. So it is difficult to convince the participants. But what I mean to say that yes, they have given the direction in which direction have the lot of scope for the research and a lot of scope for the to become an entrepreneur, to guide the students in a proper direction. Hope this workshop will be useful, and particularly few days ago, World Economic Forum, our Honorable Chief Minister Chandrababu Naidu Garu, yes, in his address, he highlighted, yes, Andhra Pradesh is going to become a global hub for green energy and green hydrogen for a sustainable development and energy reforms. Yeah, this is the motto. With this motto only, we started in our college as well as in our university. Yes, lot of programs and a lot of funding also promised by our honorable vice chancellor. Conduct more programs and do practicals and research in this direction. So this is our motto in conducting this program. Yes, so these 6 days we have organized 13 sessions. Those sessions include advanced materials which are helpful enhancing the efficiency of the renewable systems the were conducted, and as well as the green energy, hydrogen, about the hydrogen fuel cells, and renewable energy applications. Integration of the renewable energy systems also been discussed last 6 days. Hope this gives you a direction to all of you. Yes, which direction you want to pursue and you want to work more in this direction, and more things, more contribution to be expecting more contribution from all of you in future days by implementing, particularly Prime Minister Narendra Modi ji and Andhra Pradesh State Chief Minister Chandrababu Naidu. Yes, they have a mission and to make the country and as well as the state of Andhra Pradesh as a hub for the green energy. I hope more contributions will come up in the near future. With this, I thank once again. I thank all the participants. Thank you very much for your support and participation in this program. Thank you, one and all. Thank you.
Thank you, sir, for insight of your for given on this program, being as a coordinator. The department will honor and thank on behalf of your contributions toward this program, sir. Now I request Vice Principal Academics, Professor Swaruparani Garu, to address the gathering. Madam Swarup.
Sir, respected dignitaries, sir, a very good evening to all of you. Respected Principal Garu, Mohan Rao Garu, Vice Principal Academics, Dikshitul Garu, Head of the Department, President of this function, of this program, Dr. Lingaraj Garu, and coordinators, Dr. V.V. Subbarao Garu and Dr. Dilip Kumar Garu, and all the participants and speakers. A very good evening to all of you. Sir, first of all, I would like to congratulate the Department of Mechanical Engineering for conducting this program, 6-day program on emerging trends, technologies in smart materials and how it can be storaging of the solutions. Really, I belong to civil engineering department, sir, but I can say nowadays we are in search of topics for research. All the students, they are literally searching, they are in need of research topics. Such programs will be helpful for the young generation or new faculty members who will plan for their research. What are the emerging trends and which topics they have to do the research. Such programs will be helpful, and I can congratulate the coordinators for identifying such good speakers that for 6 days continuously, consistently, 13 seminars or 13 hours or sessions are conducted. I can say how seriously you have identified the speakers, and on behalf of the college, I thank all the speakers for sparing your valuable time for our college or for our department, sir. And again, I want to reiterate that our mechanical engineering department of UCEK, JNTUK is always in the forefront in conducting such programs. Every time I say the same thing, they are in the forefront compared to other departments. I congratulate the head of the department and both the coordinators for this wonderful program. Thank you very much.
Thank you, ma'am.
Thank you, ma'am. Now I request another guest of honor, Vice Principal Academic, Professor GVSR Dikshitul Garu, to address the gathering.
Kindly unmute it, sir.
President of today's evening function, Dr. Lingaraj Garu. The chief guest of today's function, Professor N. Mohan Rao Garu, Principal, and my colleague, Professor Swarupa Rani Garu, Vice Principal, Administration, and the coordinator and senior professor, former registrar, Professor V.V. Subbarao Garu, and co-coordinator, K. Dilip Kumar, Dr. Dilip Kumar Garu. First of all, big congratulations to all of you for conducting such a wonderful program. And then hearty congratulations to all the participants, and congratulations and thanks to the speakers. I can see that we have speakers from a couple of speakers from abroad and industry also, it seems. It's such a blend of experts from industry and academics is the most sought after thing these days. So I really appreciate the whole team who have conducted this wonderful workshop. Emerging technologies in optimizing renewable energy systems with smart materials and storage solutions. So whenever I come across the word optimizing, just some bells ring in my mind, because it is basically a optimization techniques is a mathematical concept. Till recent days, optimization, we take the honor in discussing about optimization techniques. But now, in the advent of the latest technologies like artificial intelligence and all that, this optimization has become machine learning and deep learning, so on and so forth. This optimization is taking a central stage in all the technical aspects of engineering art. This thing. Now it's nice that in this title of this 6-day workshop, emerging technologies in optimizing renewable energy. That is renewable energy is also a wonderful, very interesting and most sought after topic these days. So it's a very nice idea. I congratulate the whole team for identifying the subject itself. That itself shows the seriousness this team has shown in conducting. And also, I'm surprised to see at the end of the day, around 7 o'clock in the evening, around 115 participants are there still taking part in the valedictory function. This is something very, very rare occasion to see. There are so many people attending a workshop till late in the evening. So very nice meeting. Last time also there was a valedictory function in mechanical engineering department. Myself and my colleague Dr. Swarupa Rani, we said the same thing. Mechanical engineering department always stands first, runs first in conducting so many academic activities like workshops, faculty development programs, seminars, so on and so forth. So really, this is a big boost for all the administrators to have such a wonderful department under their belt. So all appreciations to the Department of Mechanical Engineering and Dr. Lingaraju for promoting these activities. And thank you all very much for giving me a chance to be a part of this evening and share my views. I request that all the participants who have taken a part in this event, this 6-day online FDP, will carry forward the good things, take away a couple of good things from this 6 days workshop, carry out the quality research, because the topic, as I said earlier, is the most sought after. Renewable energy is one thing, and then adding with that is optimization and emerging technologies. So please carry forward what your experts have told you. Be in touch with the experts and roll it on further. And I wish you all the best. And once again, I thank you all for giving me a wonderful chance. Thank you.
Thank you, sir, for your site. And last 6
No.
days, hello. Yeah,
Lingaraj
during
garu.
the last 6 days, every participant, more than 100 participants are there till 8:30 p.m., sir. We thank all the participants for sparing their valuable time towards this workshop. Now I request today's chief guest, Professor N. Mohan Rao Garu, Principal, University College of Engineering, Kakinada, to address the gathering.
No, before that, Lingaraj garu, before that, ask the feedback from the participants. If you
Feedback, actually,
no, one or two.
Dilip Kumar will share the link and they will.
No. Lingaraj garu.
Yeah, yeah.
Yeah, you just
Moral
ask
feedback,
one or
moral
two.
feedback. Yeah.
Yes.
Now I request
Customer-
all the participants give some oral feedback. Anyhow, online feedback will be taken by the end of this validity session. I request one or two participants give your valuable feedback from oral feedback from your side. Any, please.
Sir, good evening, sir. Hello.
Yeah, one by one, please address yourself
Okay.
and give the feedback. Thank you.
Okay. So, good evening, everyone. Myself, I'm Ravi Teja. I was pursuing my PhD, part-time PhD, at JNTUK Kakinada. And present, I'm working in an MNC as a data mining engineer. Coming to the this 6 days FDP, I was the lectures or the presentations were so great, and the last topic or the last session was fabulous in such a way that whatever I was doing the day by day work, so the same concepts are such concepts are repeated again once again in this lecture, so that make me more overwhelming. And so thank you all, and thank you Dilip sir for conducting such kind of Atal FTP, online FTP. And thank you JNTK. Thank you, sir.
Yeah, thank you. And any other, a few
Sir,
more.
Good evening, sir.
Sir, this
Yeah,
is
address
Professor.
yourself, ma'am.
Sir, this is Professor
Good evening, sir.
Hello. Hello. Sir, this is Professor Nagamaleshwar Rao, sir. Thank you very much, sir, for giving an opportunity to be the participant of this excellent Atal FDP program. And actually, sir, what we observed that the keynote speakers, right, the experts, they delivered actually the hands-on experiences, and especially regarding renewable energy and electrical vehicles, so that you have chosen right persons to be the speaker, sir. So that the credit goes to the coordinator V.V. Subbarao Garu, as well the co-coordinator Dilip Kumar Garu. Sir, thank you very much, sir, for empowering our knowledge in case of in this field, renewable energy sources. So thank you very much, sir.
Sir, good evening, sir. So this is Varaprasad, Dr. V. Varaprasad, working as an assistant professor in the mechanical engineering department. So first of all, I thank you, the University College of Engineering, Kakinada, Atal FDPs, and Dr. V.V. Subbarao sir and Dilip Kumar sir for conducting this FDP program. It was really a nice experience to be a part of this FDP program, sir. I have learned a lot, and I am forever grateful to the organizers. In the present scenario, online FDPs are widely conducted in different educational institutions, providing easy access to the participation. We teachers are looking for new innovative ideas to update ourselves. This FDP allowed me to experience about the practical aspects of the theoretical knowledge. We connected with professors all over the country to get the knowledge on different topics like renewable energy systems with photovoltaic grids, hydrogen storage, applications of power electronics in smart energy systems, energy efficient electric vehicles, etc. So professors like Ishwar Prasad sir, Anil Kumar, Anshuman Dalvi, Venkat Reddy, and Chandrasekhar, Shivarao sir have enlightened on various topics. So once again, I thank the entire team for conducting this FTP and looking forward for such programs in the future. Thank you, sir.
Thank you, Varaprasad garu. Yeah, any female faculty feedback, please? Female
Good
participant.
evening, sir.
Yeah, you address yourself, ma'am.
Sir, I'm Fani Sushma from JNTUK Narsapet, sir. I'm very glad to see you all, sir, and thank you so much for giving us this opportunity, sir. Like when we started this workshop, I was wondering what is the how would be the topics in this, and when we entered into it, it was started with how the battery systems and renewable energy is working out and all, and it really overwhelmed every area. Now, there is a big question for me where we can start this as a research area, or there is a lot of things to learn in it. What we were still is, I think we are in the surface of the things that we know, and there is a lot to learn, and it's a ocean. And today, last session covering IoT, integration of all this. Being a mechanical engineering, I didn't ever think that we can integrate such a great way the IoT and all, and computer science faculty also who has dealt with it. Really, it was an awesome session which covered all the things, and physics faculty who has covered the topics, and few electrical. Yesterday a madam was talking about power electronics. That was a buzz name for me every time when electrical people used to say it is a power electronics. But yesterday, when we came to know how it is useful for us and in what areas we can work as a mechanical engineering, it was really shocking for me. And these things, I think I recently completed my doctorate. This would be a new area where we can start throw a light slowly and slowly move into it. And thank you so much for JNTUK for organizing such a wonderful workshop. And by the bottom of my heart, I thought that this complete week is a knowledgeable week, where I was not putting my pen down, something or the other I was writing and scribbling so that something will get into my mind. Later we can search and move on it. So thank you for making this week in 2025 a knowledgeable week and a tremendous wonderful week. Thank you so much, sir, for giving me this opportunity also.
Thank you, ma'am. Actually, we are out of the time. Next, immediately, all the participants supposed to write the exam as well as the online feedback. So, I request today's chief guest, Professor Mohan Rao Garu, Principal, University College of Engineering, Kakinada, to address the gathering.
Okay, thank you, sir. I'll be brief. Okay, so that I could understand. So because it's time is nearing to your test. So I congratulate on behalf of our University College of Engineering Kakinada, both the coordinators from the Mechanical Engineering Department, Senior Professor Professor V.V. Subbarao Garu, and co-coordinator Dr. K. Dilip Kumar Garu, for putting a lot of efforts right from starting, initiating the efforts in getting the approval from AICT, and after bagging this approval, and they have made a lot of efforts in conducting this program and successfully completing that. I congratulate them once again, sir. Based on the feedback, I could understand that a lot of lectures have gone on this topic, where the renewable energy systems have been studied or taught to the students from the materials perspective, and the energy that is tapped, how it is to be stored, and later use of the tools like AI in integrating this all the materials technology and the storage devices in finally getting using this energy for our useful purposes. Okay, and I definitely I can say that these lectures have formed a nuclei for your further research. Okay, so this and I thank the coordinators once again for putting the lot of efforts. Okay, Even if I say 10 times or 1,000 times, it is less. Okay. So now because your participants are about to take the test, all the best to all the participants. Okay. So to their tests, and hope all of the participants will come out successfully. Thank you also for giving this opportunity, and I hope the participants are definitely got benefited. Thank you, sir. Thank you.
Thank you, sir. Thank you for your valuable side. And now I request Dr. Dilip Kumar Garu to give the vote of thanks as well as the post validity session, what the things are supposed to do by all the participants. I request Dr. Dilip Kumar Garu to give vote of thanks.
Thank you, Dr. Lingaraj Garu, for giving me this opportunity. After post-workshop, every participant has to log into the ACT, their own Atal account, and appear for the test. After the successful completion of the test, you're supposed to give the feedback so that you'll get your certificate directly from ACT Atal to your account within few seconds.
Sir, shall we have a photograph, sir?
Pardon, sir?
Shall we have a photograph?
Yeah, definitely, sir. Just 1 minute, sir. Give me 1 minute. I'm concluding this important vote of thanks because it is not simply success. It is a success of the unity among the university and the college. I am supposed to thank everyone. That's what, sir. 1 minute, sir. Give me 1 minute. First of all, above all, I thank Almighty God for giving me this opportunity and beautiful help to execute every plan that is assigned to me by coordinator and to execute to his expectations. And then next, I take my immense pleasure to thank university administration, college administration for providing every kind of infrastructure facilities to make this the FTP grand success over past 6 days. And also in the inauguration session, we had chief guests. I thank every chief guest and the valedictory session also. I personally thank every speaker. Sometimes there is no network facility. That issues also we have come 1 or 2 times, even though they arranged within a short period of time, within a minute, they could be able to do it without any interruption. Thank all the speakers. There were 13 speakers across the country and across the world. There are 2 speakers from across the world. Thank you, sir. Thank you very much for the speakers. And I'm delighted to thank this university providing us network facility, the director, university internet and the network administration, Dr. A.S. Chakravarti Garu. And also because I am doctorate in the machine design, but I have an opportunity, but Dr. V.V. Subbarao Garu thrown us a light on how important is energy, how important is environment. Then we started working on environment, but we have little knowledge. Then we took the help of certain PhD students who is appearing for PhD in the area of energy, especially a person called he submitted his thesis, Kamesh Garu from MGIT, Hyderabad. He has worked a lot on in this area called energy and renewable energy technologies, MTech. We are after IST. We took help from Dr. Anil Kumar. Their efforts is valuable in making and instrumental in making this program a grand success. I will definitely mention their support and help regarding this smooth execution and functioning of this FTP. And also present media and electronic media for the wide coverage of this event. And above, I thank Dr. Lingaraj Garu helping, supporting, and for arranging every infrastructure facilities for the success of this FDP. And behind me, Dr. V.V. Subbarao Garu, this is the plan.
It's
of
the time
sir
is
executed by me. Thank you, and principal sir, vice principal ma'am, and admin Soroparani madam, and academic Dikshital sir for accepting our invitation, gracing the occasion of this, and above all, my wonderful participants. They're all earned their knowledge and their certificate soon. So with which I conclude my vote of thanks. Thank you one and all. Thank you participants. Thank you college and university for giving this opportunity. And also I feel very happy to say that Atal is supporting a lot for the, I appreciate Atal also. Thank you, sir. Thank you very much, sir.
Thank you, sir.
Please,
Thank you,
just
sir. I thank on behalf of University College. I thank all the people who have helped my colleagues, vice principals, Dikshital Garu, Sarupa Madam Garu, coordinators, and heads of the department, all the faculty and staff of the college. I thank all of them for making this program a grand success. Finally, I congratulate the participants. Thank you.
Thank you, sir. One
Thank
second,
you,
sir.
thank
One
you,
second.
Anand.
We would like to take one photograph,
Take
sir.
the,
Please,
take the exam
all of
first,
you,
please.
turn on your videos, sir. Please,
Yes.
1 second.
అవసరం లేదు బాబు సరే
Sir, one photograph, sir.
No, వాళ్ళకి టైం అవుతుంది. They are
Please, sir, one
they
photograph.
are running out of the time.
All the participants,
Okay.
would you please turn on your videos? So in our midst, Dr. Sundar Rao sir also, he is excellent.
Okay.
Session. Okay, sir. One minute, sir.
Thank you.
Okay, second. One second.
Dilip.
Sir. And last
close it.